in the mass 2, sorry. In this problem we're asked find the acceleration parallel to g and theta. So we have the following forces. We have the force of N, normal force, going upwards. Then we have the weight going downwards. Here's the angle theta. But the acceleration is going to be parallel to g and theta. It's going to be the displacement s this way. Therefore, based on Newton's law, we could say the sum of the forces of the acceleration direction is going to be equals to mass times acceleration, which is what we're finding right now. We also know that this little side right here in this triangle, this side is going to be adjacent to theta. It's going to be mg cosine of theta, and on the opposite side is going to be mg sine of theta. So the force is going in, let me put another color, in this direction, in the direction of s, which we want, is going to be mg sine of theta, which is what we're going to use. And that's going to be equal to MAS. Therefore, we can cancel out the masses, and we end up with this, which is the final answer.